Hey, good morning, everyone. Thanks for joining. I think everybody is doing well and your family is safe. So, this is the third level session on DevOps episodes on AWS User Group Malta. And so we have done two episodes previously. So first one is 100 level session and second one is a 200 level session. So we don't have it's more time to cover all everything in DevOps, because DevOps is like it's an ocean. So it's not simple that we can cover everything on 3 hours, right? So we have tried as best to give you a clear picture of how DevOps in a reality. So you can check. So I'll be going to share my screen and show you that whatever the previous sessions, it was there in a AWS Meetup channel. So I'll be showing you the screen first, so that if you are new, you are the first time you're joining the session. So we have done a two episodes previously on DevOps. So I'll be showing that screen right away. Just give me a moment. Okay, so this is the our meetup page. So you can go AWS User Group Malta. In a meetup page, you can find this page. Here you have all recorded sessions on 100 level and 200 level. You can find the YouTube links here. So you can view these YouTube links. 100 level, this is a basic, and 200 level is like intermediate. So we have done a quizzes too. All right, we have given the prizes to whoever got the first prize and quiz. So even today also we have the quiz. So whoever joined the session, so don't leave the live stream. So because end of the session, so we will be having the quiz. So once you answer correctly and you are the first winner, so we will be giving you the prize, so which can be an AWS credits. So it will be sharing you in an email, so the credit coupons to your email ID. Okay, so let's get started. Here. Okay, so DevOps Malta. This is one of the final session, and as I told you that we have done previous sessions, you can find in a meetup group. So now, I just as I told you, this is a 300 level session, which can be the session can be given by the speaker. So I don't know what are the features and the services which are including in this. So he's going to explain on this. So I welcome Mr. Prasanjit Singh. So Prasanjit Singh is a DevOps, a cloud and DevOps director working in Stars Play. So it's in Dubai, United Arab Emirates. So he's done great work for us for AWS User Group Malta, and as per our request, so he's going to speak for the three episodes. And today agenda. Okay, so what is the agenda today? So we are going to have the session on the DevOps that I told you, episode 3, and we have the quiz. I told you, do not leave the live stream. Please be seated and wait for the quiz. Answer the questions. If it is wrong, if it is right, doesn't matter. So after that, maybe if you have any questions on the quiz also, you can shoot the questions in the chat. The chat will be open every time. So maybe the speaker cannot answer you in the middle, but I am trying to give my level best to take some of your answers at the end. So whatever the questions you are asked in the chat, so it will be appear on the screen. So that's it. And there will be a Q&A. I told you that it is open always, so you can chat. So the viewers which are connected from Facebook, Twitch, and YouTube, you can chat, you can ask, shoot your questions in the chat, so I can see your questions from my panel. Okay, so now I'm going to introduce Mr. Prasanjit Singh here. So I'll be playing a music for you. Hey, Mr. Prasanjit Singh, how are you?
I'm good, Ganesh. Thanks for having me. How are you doing?
I'm doing great. So thanks again for the this episode. So we have done very good things previously, 100 level and 200 level. Maybe guys, if you miss something to ask Prasanjit Singh, you can ask the previous question. So that doesn't matter, which can be a technical. Okay, which cannot be a social. So I think I already told Prasanjit Singh is working in Stars Play in Dubai. So he's done a great job, and I think you are also speaking another community session, right? So I've seen some post in LinkedIn, right?
Yeah. I keep getting involved in different AWS related talks and DevOps related talks. So it keeps happening.
Okay. Thank you very much. So over to you. So you can proceed to discuss now.
Thank you. I have started sharing my screen. Hope you all can see me. Hello, everyone. And it's a privilege to be speaking here at AWS User Group Malta. And we had previous sessions, as Ganesh said, like we have the recordings of the session in the AWS User Group YouTube channel. So those who have missed out can watch them. And obviously, you are watching today's session live. So if you have missed out the previous ones, you can watch them again. And today's session also will be recorded and put up there. So you can follow that. And as Ganesh also said, like DevOps is a vast topic, so it would not be possible actually to cover it in 3 hours, like for 1, 2, and 3 episodes. So do not worry. Today I'll try to cover like the rest of the things that are remaining, but that will give you a high level view of what the DevOps processes are and what are the different tools that we use to uh, do DevOps practices. But we will have more episodes, like not from this episodes 1, 2, and 3, but we will have specific deep dive sessions in the future, because I'm always associated with this user group, so no problem. In future months, we might have more sessions specifically on single topics. Like say, one day we'll do only ECS, one day we'll do EKS. Those who are interested in Kubernetes, if someone is interested in say Cloud Formation, Terraform, Ansible, so we can pick one topic a day and do it in the future. So, but this 1, 2, and 3 episodes you have to watch again for those who have missed out, to know the basic concepts of DevOps, so that you can get started doing it. If you are already not adopting DevOps in your organization, you can get started with it. So, a quick recap: what we already did. We learned what DevOps is and why it is used. We learned about CI, how code is continuously pushed into and built using CI tools like Jenkins. Also, you can use CI tools on AWS code commit and code build and code pipeline. And we know how to deploy using Jenkins. We deployed a Python Flask app, and we also built a Java app. So you can watch the previous episodes. So we came to know about all those things, and we also knew what is the release cycle looks like first you plan, then you write the code, then you build it using the build commands, and then you test and release and deploy. So that is how the pipeline moves. And what are the DevOps counterparts of Jenkins we discussed, like code deploy, code commit, and code pipeline. These do the same things that Jenkins does, but we focused on Jenkins because most companies will have Jenkins, those who are moving into AWS. So you have to know both the sides. But yes, you have to deep dive into it and know more about declarative pipelines that we discussed in the previous session. So watch the previous video and then do some more research on your end. We also discussed how to run Docker containers, what containers are, and we discussed how Docker containers can be deployed using pipelines by doing a simple pipeline job. So these things we had covered. So today what we'll do, we will do an important aspect of DevOps, that is called infrastructure as code. and we will combine it with a pipeline. So what is the plan? Let me explain you. So I'll tell you what infrastructure as code is first. Once you understand what it is, we will use one infrastructure as code tool that is called Cloud Formation, and we will use that tool to build a simple pipeline using AWS, not using Jenkins, because we did Jenkins, we basically know how it works. We'll do something different. So using Cloud Formation, we'll build a pipeline, and using that pipeline we will deploy a simple we'll deploy a website into a EC2 instance. So what Cloud Formation will do, it will create a CD pipeline, continuous deployment pipeline, and it will also build a EC2 instance, and it will run that pipeline and deploy the website code into that EC2 instance, and we will be able to see the live website if it works properly. So that is the plan. So we'll do everything automatedly, not using AWS console manually. Okay, because that is the point of DevOps, because we know AWS CLI and AWS console. So if I ask you to host a website using the console, you can go and create a EC2 instance and then install HTTP, yum, install HTTPD, you get an Apache server, then you take the code and put it on the www.html folder, and your website is up. So that one we know, but we are going to do this automatically using Cloud Formation. So that is the first plan, and this is the flow that will happen. We will have some magic there, like when the developer pushes new code, you will see after the pipeline is built, automatically that code will go to EC2 instance without touching anything. So how that happens? Because as soon as the code is committed, the code build will automatically deploy it, and the deployment process will push the new code into EC2 instance. So that is the real demonstration of a continuous integration and continuous deployment pipeline. So that is the first thing we will do, but that is not all. So I'll try to do things quickly because we have 2 demos actually. So this is the first thing. Next, we will move on to understand orchestrators. We will build a ECS cluster. Again, we will not do this manually. We'll do it using Terraform, because you did Cloud Formation in the first demo. So now, after that is over, I'll tell you some basics of Terraform, and I'll give you a template of Terraform that you can use when you want to build your own ECS clusters. Then I'll show you how it works, and on that ECS, we will deploy a Node.js React app. So that will give you an idea how a normal, say, real world application works. So that is something we'll do. So let's quickly get started into this one, infrastructure as code, and about Cloud Formation, and about AWS Code Pipeline, how to do things automatedly when you are using a CI/CD pipeline. And all the links of the repositories and the videos, everything is there in this DevOps episodes, and we'll share it on the Meetup page also. And here is all the code. So in the previous episodes we had done this. Today we'll do these 3. So we will use these 3 codes and repositories. I have already opened all the tabs here, so we'll do one by one. We'll go and finish these demos so that you understand it. And do not worry, if you go to this page, you will get these links. So we'll share it in the end. So now you focus on what I am doing. So because everything is arranged properly, you will be given all the links of these. Okay, so this is a repository code pipeline code deploy example. So this is a demonstration which will show you what infrastructure as code is, and it will also show you how to create using a CI/CD pipeline using Cloud Formation. So in that way, you will learn infrastructure as code as well as you learn DevOps pipelines. So you kill with one shot, you kill 2 birds. So that is what I have combined both of them together. All right. So before we begin, let me just tell you what infrastructure as code is. We can build infrastructure using AWS consoles. Okay, just like I was saying some time ago, you want to build a EC2 instance, a virtual machine, go to the console, click there and build a virtual machine. Pass all the parameters that you need, like what size you need, what memory, CPU, what operating system. You define all those parameters and then you deploy it. You get a new instance in a few moments. But one has to do manual intervention in this. But in DevOps, what was the principle? Like we had discussed that DevOps encourages automation, and DevOps is done to increase your velocity of deployments. So how can you increase your velocity of deployments? By using tools. So infrastructure as code tools are also a way to do these things. So Cloud Formation is one of the infrastructure as code tool, where what you do, instead of doing things manually, you write a definition file. So you write a YAML file or a JSON file where you define what you want. Like I want EC2 instance, I want it in this region, I want the size should be this, I want a flavor should be a say T2 micro, whatever you want, you have to define in that definition file. And then you define everything there, like not only the instance, you define what VPC to create, what should be the subnet mask, what should be the IP address range. You can define which security groups to add, which ports to open, which ports to close. Everything will be in one file. And when you execute that infrastructure as code file, you get your infrastructure built quickly. And what is the advantage of it? The advantage is you do not lose anything. Say someone deletes your instance, you can just run that script and create it again in few minutes. So that is the advantage. Like you do not worry about your infrastructure loss or server if server goes down or something. You do not worry about any loss of data. You can easily recover because you have everything there. And also it helps for those who are migrating from one cloud to another, or from one region to another, or from one data center to another. So infrastructure as code helps you do that. And when you're using Cloud Formation, you are only doing it within AWS. But if you are doing multi-cloud, then you will be doing using Terraform. So we will come to Terraform in a while. But first, let's focus on AWS Cloud Formation. So what is Cloud Formation? It is an infrastructure as code tool, and you can use it to automate building or provisioning of your infrastructure. And remember, like when you build or provision your infrastructure using Cloud Formation, you can also use that same script to destroy everything. Say you want to remove all the instances you did, so you can destroy that. But in production, you have to be very careful when doing destroy actions. That is one thing. Second, when you have built something using Cloud Formation or Terraform, you have the independence of editing that infrastructure. For example, say you have a cluster which has 5 Apache servers. Tomorrow you feel that it is not sufficient, you want 10 servers. So you can just change the manifest file, like your definition file, where you have mentioned how many nodes you need from 5 to 10, and rerun that script. So it will not touch the existing ones, it will just add the new ones. So it is like these infrastructure as code tools maintain the state of the system, which is very important, because when in production, you would not like to harm whatever is running. You would like to add or subtract, but you don't want to touch anything that is already healthy. So if it is like if Cloud Formation, just if you ran it again and it started killing the existing ones and deploying it, then it might cause problem in production, but it can maintain state as well. So you have tools like Terraform, which also maintain state and allow you to do all these activities. And then what is a delivery pipeline? As we already did that in Jenkins, it is the CD part of the pipeline. In CI part, what happens? User writes the code and commits it. The code is built and stored as an artifact. So that is the CI. In CD part, what happens? You deliver that artifact into a live server, So if that server is not present, you create it using CloudFormation or Terraform, and then you deploy your code there. Okay, so that pipeline which takes the artifact, packages it, tests it, and deploys, that part is known as the delivery pipeline. So why we are learning these two? Because we are going to combine these two concepts to build a delivery pipeline using Terraform. So that is why these definitions. You can go through rest of the stuff, because I will be demonstrating and explaining these things. But I know not everyone can remember everything while I am teaching. So it's better to like revisit it. That's why we have kept all these notes here, so you can follow this. Okay, so what we are going to do now, we are going to use CloudFormation to build our code pipeline. So it will have all these AWS services. So this CloudFormation will build all these AWS services, code pipeline, code deploy. It will use CloudFormation. It will create a EC2 instance. It will store the artifact in S3 bucket, and it will also create IAM rules. So all these things will happen like magic using CloudFormation. So what is there in our scripts? Let's understand the script first, then we will execute it so that you know what's going on. Okay. And when you are doing CloudFormation, you can use this as a template to build your own CloudFormation scripts. Also, you can use ready-made CloudFormation templates available in the AWS Labs GitHub repository. You can just search AWS Labs. You will find a lot of lab CloudFormation templates, which we use normally to modify and do it. For example, how did I build this demonstration? I did not write it from scratch. No one does actually, because you have to do things quickly. So what I did, in a matter of few hours, what I did, I got a repository from someone in the GitHub, and then I modified that template to create our use case, because our use case needed infrastructure as code and delivery pipeline both. So I just modified and combined both. But normally you will find templates to create EC2 instance, create ECS cluster, create a S3 bucket, things like that. But you can combine them and write it. How to do that and what are the contents here? Let me show you. So a CloudFormation template is normally a YAML file. That's all. No more, no less. So very easy. Only this one file is actually doing the magic, CloudFormation. Okay. The rest are all the supporting stuff. I'll show you what is inside. So app spec.yaml. What does this do? This is the specification of the application that is going to be installed and what will happen when the installation is done. So here what it is doing, here we are mentioning that what is the operating system and what is the path where that website will be deployed, and what are the scripts that will be run when the website is deployed. So before install, you have to run this script to install Apache and all those supporting stuff. Application start is starting the process of Apache, and validate service will check whether the port is up or not after this is done. So that is one file which is important here. Next, what is inside this app? This is actually the website. Simple, it's a single page index.html page. So this is I'm just echoing automation for the people, so that's all. So whenever whatever your app be, you can put it inside it. It might not be this simple. In a real world app, it will be a Node.js or a PHP app. So you can just put the contents here. And we are using a Lambda function here, a JavaScript Lambda function, to write a test case. So what I am doing here is, this is just a test case in the pipeline. So after deploying, it is checking whether that text is there or not. If it is not there, then it will fail and it will try to redeploy it. Okay, so that is another thing. And in this deploy, you have those scripts that I said, like one script will start the Apache, one script will install the Apache, and last one will validate whether it is up or not by doing a curl, okay, and see whether there is a 200 response. Now this tag.yaml is the most important one here, which is the cloud formation file. So what is mentioned here? Here we are mentioning that this cloud formation is to host a static website by creating a EC2 instance and doing all those stuff, installing Apache, starting the process, taking the code and putting it inside that wire www.html folder and so on. So this is the description. Then in this parameters section, we define from where the code will be pulled. So I have kept the code in GitHub. So here I am mentioning that different parameters that is required to pull the code from GitHub. So you will need the owner name, you will need an OAuth token. I'll show you how to get that. And we'll need the name of the GitHub repository where this is kept. So this is the name of the repository. And that's all. So when you have these three stuff, it can pull the code. And then what does the other things defined here in the file? One is the VPC. So this parameter will create a VPC there. Okay, we are using a default VPC to be created and a subnet. And then here there are some mappings like which region you want to launch your instance. So I have mentioned some regions just as an example, but by default I have kept it at US East 1. So it will use this AMI. So according to region, the AMI ID changes. So whatever EC2 mesh, Amazon machine image you want to use, that you have to mention here. And then are the different resources that will be created using this cloud formation. So we will create a S3 bucket where it stores all the artifacts. Like it will take it from GitHub, zip it up and put it on S3. And from S3 code pipeline will pick it up and deploy it on EC2. So that is how it works. So that's why we are creating a S3 bucket also. And we are assigning IAM roles. What is the use of these IAM roles? See, in AWS, it is a very secure environment in the cloud. It's not like everything is open and people can just pull and use it. Okay. So we define certain policies, like code pipeline can take this code from S3 bucket. So someone has to give that right to code pipeline to take it. Otherwise, code pipeline will not be able to access the S3 bucket. So those policies are defined using these IAM roles. So we are giving a allow access for IAM to read from S3. So that is the thing here. Similarly, where the logs will be kept, that rights are given here. And for code pipeline to be able to put the objects in S3 or write the logs. So all those types of rights that are required, IAM policies, so those are defined here in these sections. Okay, so whenever you are deploying anything and want to add IAM policies, you will do a policy name and then you will define what you want to do. Similarly, here whatever policies you want to apply, allow code pipeline to do, that is mentioned. So it can provision EC2 instances, it can provision load balancers, CloudWatch, S3. So we have given all the permissions. For this demo, only S3 and EC2 will be required, but just provided everything because this is a template. You can just use it for your own and modify it. Okay. And similarly, we are also using a Lambda function here, which is running that test case. That is also optional, but I have added it so that you get a complete template with the test case also. Okay. So this is all about the Lambda functions and the test cases. And then in the code pipeline section, it is defined how to create the pipeline, what will be the different stages of the pipeline, and so on. So you can just use this template and follow everything. You don't have to make any changes in these sections. only section where you can make a change is here, but I have also made this stateless, like you can just use it as it is. It will ask you for whatever it needs, like for these parameters, because GitHub owner will be different in your case, because my GitHub repo is different than yours. So it will ask you that one. You will give your repository name. Your OAuth token will be different from mine, so you will do that, and so on. So this is how this cloud formation template is defined. Similarly, the EC2 instance profile is defined, like what is the instance type. You can see here instance type. Region had been defined in the top, so it knows which region to deploy. And then in the user data section, we are mentioning what to do after creating that instance. Like after creating, you need certain things installed in that server. So post deployment stuff you can mention here, like you want to install Ruby, you want to install wget, or whatever you want to install, you can just put all those scripts here in the user data section. So these are run after the instance is up. And then subnet id of the EC2 instance, and all those stuff that is required for the EC2 instance to be up is defined in this section. Similarly, I told you there is a Lambda function, a serverless test case will run there. So that is for this section, is for that one. And finally, in the output section, what is there? When the server will be up, it will give the IP address of the server or the host name of the server, a public DNS name, so that we can see whether our website is running there or not. So that is about this cloud template. Use it. I have written all the steps in the end because I know no one will be able to remember it because I am going fast. So everything is here. If you go towards the end, you will see how to do that. So all those steps are here. So you have to just this repository and bring it to your laptop. How do you clone? Just write a git clone and space this path. Then you can clone it, or you can just download the zip file and open it. So you will get all the code in your laptop. Once your code is there in your laptop, go to the terminal and enter that folder. So this is that code pipeline, code deploy example. See this one. So I have downloaded it and I am inside that folder. So if I do a ls, I will see the same files which is here, lambda, deploy, app, these things. So I am on the same location. So I have all this stuff. Now how to run it? To make it simple, I have written a setup.sh shell script. So if by running that shell script, we can run this cloud formation. What is inside? You can just have a look. Here inside, it will ask you some questions like what is your stack name that you want to build? You can give any name. What is your repo name? What is the owner name? Whose repo is this? And the OAuth token, so that it can pull the code from the GitHub, because no one can pull your code from the GitHub if it is private. But mine is public, but still to show you how it is done in a production, you cannot keep it public there. So you have to use a OAuth token. So it will ask these 4 questions, and then it will run the cloud formation script and put all those variables that are inside that script and create. And it will take a few minutes, and once it is created, give you the link of the server that was created, so you can go and see that. But we have answers to the questions or not? Let's check. Stack name, we can name anything. GitHub repo, we have it. We have the repo at owner. We have, like, I know the name of my GitHub username. OAuth token, I do not have. So where to create the OAuth token? That also I have mentioned here in case you forget. OAuth token with access to repo. So just click on that, open it. It will take you to GitHub. You have to log in if you are not logged in. and it will take page like github.com settings token, but you have to log in your GitHub. Then here you can generate a token, and be careful, like these tokens should not be shared with anyone, okay? Otherwise they can be able to take everything from your repo. I am doing this for a demonstration, so you will know my token, but I will delete or destroy this token after the session, so it's fine. But when you are doing it on a production or anywhere, make it a point not to reveal this to anyone. That's why it was not, I could have easily coded this token inside that cloud formation script, but that's not a good practice. That's why I did not keep it here. I could have written it inside instead of putting it as a variable. But anyone who checks this repository can be able to steal all the code. So be careful about that. For now, I'm generating a personal access token. Here you can name it cloud formation token. Okay. And what access we will give? CloudFormation just wants to read the repo, so we don't want to give him all these write or admin or all these access. So only give repo related access, so it can deploy, read, and all that. And then generate token. So there you will see a number like this string. So copy that one. That is the answer to the question it will ask. Now let's go back and run that script. So I'm clearing this again. Let me show you. So we have done this setup.sh to run the formation stuff. Setup.sh ask us a few questions. Enter the stack name. Okay, let's name it AWS User Group Malta. So that is done. Enter the GitHub repository. So here you have to name the repository, not the full path, just the name. So let's go back. Our repository name, only this one, not the full path, because it knows it is a GitHub. Those things defined. So GitHub repository is this. Owner. What is the owner? It is your account name. Like my name is this one, so this is my account name. So just copy it the same way it is there, mentioned there. Okay. And the OAuth token. This is where that token will be needed. So I copy this, paste it. Okay, now it will start creating a CloudFormation template. I hope I did not keep a space here. If it fails, we'll do it again, but while I copied, I don't remember. But anyways, so now it will start creating a CloudFormation templates, but we can see what is going behind the scenes. How? Let's go back to the AWS console. Cloud, you can search for CloudFormation. See, there would be concepts which you don't understand. You can ask questions even later on also, because just forward it or put it on that YouTube channel. I'll go and reply it there on our YouTube channel. Or you can just mail me also, or send the questions to Ganesh. He can. We are always in touch, so no issues there. Because you have to, sometimes you might have questions after watching the video later on, so no worries. So here if you click that, you can see a template is being create in progress. But what exactly is going on? You can click events and see that different steps are going on parallelly. Some of them are over, some of them are in progress. So it is doing all those steps that was defined. It created the stack, and it is creating an artifact store, IAM roles. It is creating a Lambda function, all those things which we mentioned. It is creating that code pipeline that will pull the code and deploy it on the EC2 instance. So all these steps are happening. So you can just keep refreshing and see it is happening or not. And once it is over, you will see a output here. And if it fails, you will see an output here with the failure message. And you will also be able to see the failure message here as well. So using that, we can debug even, because not everything might work at once. If it fails, it's good. You will see the reason here, and accordingly you will fix it. It will say that unable to uh, read from the repository or stuff like that, or if it is a policy issue, or sometimes some spelling mistakes might be there. So there can be issues. So because we are engineers, we have to fix them based on the status and reason. So no worries about that. So let's just wait and see it works or not. So it's still create in progress and it will take some time. But just imagine if you were doing this manually. So just imagine what will happen. It will take so much time. You have to create a EC2 instance, you have to create code pipeline, code deploy, Lambda function separately, all the security groups, VPC. So it will take around 2 hours or 1.5 hours at least to do all this stuff, the entire pipeline and the entire infrastructure. But here it will do it in 5 minutes, maybe maximum. Okay, so that way it's beneficial, and you can destroy it at one go and even recreate it again if something is wrong. So these are the advantages of using infrastructure as code. And even say I want to migrate my server from here to some other region, I don't have to do anything. I'll just change the region or change the account and run the same stuff in the new account. So that way all the stuff from here will go to the other account. So easier to migrate. So that is another reason for using cloud formation or infrastructure as code templates. So take some time, and once it is created, we will get an information here that the formation script is created. So we have to wait patiently, and meanwhile, yeah.
Can we have the questions meanwhile until the stack is complete? So
Sure, sure,
we
sure,
okay. So we
sure.
have a couple of questions uh, from Shiva. Could you please suggest or explain the scenarios, like if organization wants to adopt DevOps culture, what are the best practices to implement or start with?
It's a very good question actually. So, for what to start when you are going to adopt DevOps? First thing, what you will do is, because that culture has to be understood by everyone. So, as a DevOps engineer, what you will do is, this is like my experience. What I did, I talked to the first talk at the top level. Like you talk to the CTO first, not with the developers, because they will say, no, this is going on. I don't want to change anything or touch anything. So it has to be a top down transformation. So how it is done, you talk to the stakeholders in the top that we are going to do the DevOps practices, and this is the proposal. And in that proposal, what will be the steps? First is, everyone should commit the code, like no doing things in the own laptop. Everyone should use a version control system. So first thing is using the version control systems and tagging each release. Like you don't have pipelines anything at that time, but only you are using version control, git, github, bitbucket, anything you are using. And every time you are releasing, that day you are creating a tag and naming it something, v1.0 or something. Start that practice first. So every time something is deployed, whether they are doing it manually, but that day they are tagging it in the version control. So first thing is done, and make it a practice that no one deploys anything without tagging. So one thing gets uh, into the proper place, and then build a Jenkins server. That will be your next point. Jenkins, it's easy for everyone to understand, because at one day if you make it cloud native with this cloud formation and all that, people will not do it because they will feel that this is this is too difficult to practice. So make a Jenkins, do some simple automations. Like for example, ask them what are they doing again and again. You can do those things using scripts. So that will be your first. Make small automations, like they are running something to keep a backup, they are running something to clear a cache. So all those stuff you put it on Jenkins as jobs and give them the links for on-demand execution. So they will run it and do that execution. So that way they start enjoying the process, like automation is happening, it's fun. Then next will be deploying a pipeline as a POC, not a live. Like you will do a proof of concept pipeline to deploy in a staging or dev environment and show them like how it is. So initially DevOps people also have to do a lot of demo and these kind of sessions. So you will show them that this is working, and when they are onboarded, and start using it on least impact projects first. Like say there is some project which is only like not affecting the production, for generating reports or something, do it on those first, because you don't want DevOps to make something down and immediately the management says we don't want DevOps. So don't go that way. Least impact project, make it a success, and people start deploying through that and automating and all that. So once that one is done, that pilot project is done, then you start applying uh, the pipeline in all the other projects which you have. And once that is done, then finally this cloud formation and all this will come in the end, because they already have servers, they already have things running. You cannot say okay, kill all the servers, I will build cloud formations. It does not work that way. Once it is done, everything is working in the pipeline level and all, then you start creating infrastructure as code. Normally what we do, or what I did, I created a separate account in AWS, because don't want to touch the existing ones in a production. There I started creating the same things using Terraform or Cloud Formation, and show them like, see, all the things are up and running in there also. And then you slowly have to switch. Now switching is also another process, like how to migrate, what is the methodology there, that is also another story. Like there are some ways in which you can just switch, or some ways you can lift and shift. Many methods are there. Okay, so meanwhile, I can see that this create complete is showing. So here some of them are still in progress, but the overall is completed. So we should be able to see here. Okay, so here we see that this is the instance where the deployment has been done. So let's try whether it is up or not. So here automation for the people, that code is here. How did it come here? Let's investigate some more. I told you it created a pipeline also. So let's see where is that pipeline. See here in AWS, different services are at different places, not like Jenkins where you can see everything in one day to it. That's why I said it is easier when you do that. But this is also a way to do it, cloud native way. And for that, you are not getting charged. Like this pipeline is not, AWS is not billing you for this pipeline. It is only billing you for the EC2 instance that you created. So it is free. So in that way, if you use these AWS tools, you are actually saving money. Instead of having to build a separate server for Jenkins, you are doing it for free. But for that, you have to reach to a level of DevOps maturity to be able to use it. So that's why I said like start with Jenkins and then go into these. Okay, here in the pipeline, you can see different stages were created. First stage is the source, where from GitHub it is bringing the code. Okay. Second stage is deploy, where it is deploying it to that EC2 instance that it created. Third stage is test. So it is running some test cases, that is in progress. So test cases still running. If it passes, then it will show a green tick here. So that is the sequence of steps that is happening. here, and we are able to see this automation for people. Now let's do some magic there. Say for example, a developer went and changed something in the code. Okay, so that means a new version or something has come up. So let's do that. Say I am the developer, I go into that app. Here all the codes are there. So I will change it. So if CI/CD is working properly, then I should be able to do what? I should be able to deploy it automatically without touching anything. Okay, so automation for the people, let's add something. Automation for the DevOps people. Okay, now it is automation for people. I will commit it, and it should trigger that pipeline again automatically because a new commit was made. So I have made the commit. Automation for DevOps people is now in the file. Okay, so keep refreshing. If that pipeline will trigger after some time, it will redeploy it. Okay, and if it doesn't redeploy, then you can also trigger it. Okay, here it is still in progress with that stage. So here you can see the source step. It has detected a change, so it is again triggered. So now it has succeeded. Now it is deploying. Once this succeeds, our DevOps will come. It will become visible. So that is how this continuous integration will keep happening. So let's wait till this one passes, and we will be able to see the change. See, you got the DevOps people. So that way it's continuous integration and deployment. So it's happening. If I remove it again from here, or say I add 2 exclamation marks or something, then after some time we will be able to see that change here once that pipeline is executed. Okay, it will take just 2-3 minutes and new code will be deployed. So just imagine in production, as soon as the developer makes the change and deployment is done. So that is like magic, like very quickly, instead of doing anything. But in production, normally this practice is not followed. This is up till test or staging environment. But for production, it is done manually. Like you don't do the auto trigger part, you do manually, because you don't want to deploy anything which is not tested properly. Okay, so that's the use case. So once it is deployed, again you will see 2 exclamation marks if that execution is complete. Now the deployment is going on again. See, deployment is over. We should be able to see. Here you can see 2 exclamation marks. So that is how CI/CD is happening, continuous integration and deployment. All right, so let's leave it at here. Yeah, one more thing. If you want to destroy the entire stack, you can just simply go to the Cloud Formation again. But as I said, like, you should not destroy if it is production. DevOps people have to be always careful and focused. Don't make any mistake, because as easy it is to build, the same easy it is to destroy. So don't do anything inadvertent and create a disaster. So is this one, if I delete it, it will delete everything that was created, pipeline, server, everything. So be careful when deleting. But for demo, you are just playing around, so you can do it. All right, so we are running out of time. Let's go to the second demo. So what did we do here? A quick recap. We created, using Cloud Formation, we created a pipeline, CI/CD pipeline, and we created a EC2 instance and we deployed that code into that pipeline. So that's what we did. Second, we will create a ECS cluster and we will deploy a Node.js, a React application on that cluster. Okay. Again, we will use Terraform for that. Just like Cloud Formation, Terraform is another tool to do infrastructure as a code. So first, what I will have to do for that is this. So this is the React app. It looks something like this. So we are going to deploy that. So what we have to do for it, in the beginning, we have to create the Docker image for this one, this React app. We will push that Docker image to ECR, because ECS is a repository that it's an orchestrator that uses Docker repository to pull the images and then deploys it. It cannot run non-Docker stuff. So for ECS, we need to create a Docker image and then deploy it. So what will be the steps here? We are the user, we will create a Docker image and push it to the ECR. That is the first step. And the viewers will be able to see through a API gateway and a load balancer, they will be able to see our service hosted on ECS. So ECS is just like a framework, just like Kubernetes. It is an orchestration framework which can pull Docker containers from a registry and run them, and it can load balance them also. Okay, so let's do that. So first step, let's create a Docker image of this. So again, same, you have to download this zip, unzip it, or git clone it. Okay, and then once you do that, go to that folder. This is that color test master. That is a simple React app for coloring a page. So it's just a demo. So this is the repo which has various files. These are all the Node.js related files, package.json and everything inside the public. Docker file is what contains how to build that Docker image. So let's build that Docker image. So how to build that? Docker build -t, that's the tag of the image. So I have also written it here as a comment so that you don't have to worry. So, and also don't make mistakes in the spelling and all when you are trying this POC. So just Docker build tag name, the name of the image, and dot. So this dot means in the current working directory you are taking all the files and creating Docker image. Okay, so this is what we are going to do first. But when it builds the image, now this image will stay inside your local machine. Okay, not in the AWS. So how to send that image to AWS? That is our next step. So image is built, but this is in my laptop, not in the AWS. So how AWS will deploy to ECR? To do that, let's go to AWS and we will search for ECR, Elastic Container Registry. So you store all your Docker images in container registry so that Amazon services can be able to access the image. So we are going to create a repository, get started. Make it private, because say in production you will be doing this as a private image. And repository name, we can name it workshop and nothing else. Create it. So here you can see it has created a repository called this workshop. Okay, and if you click here, you can see there is no image. We have to push that image. So how to push that image? It's very easy. You just click on this view push commands and you will see all the commands to push your image. Okay, so what I will do is just copy this and go back. You should have AWS CLI installed in your system, and then you will be able to run this AWS command. So this command is to log in into the AWS ECR, and then this command I have already done because I built that image in my local, so this is already done in my case. So now I am just trying to send that image into AWS. So I am doing the third command. This tags the image, and the fourth command pushes the image into AWS repository. So this one pushes the image there. So it will take some time to push that image into the repository. And once the image is pushed, we will create the ECS cluster. So how do we do that? For that, we have to go to this Terraform workshop repository. Those of you who are thinking like this is too much or getting too difficult, then just you have to revisit that video and see what I am doing. So when you do it at your own pace, you will feel like this is easier. But it's nothing. I created a image, then I pushed that image to Amazon ECR. Now I am creating a ECS cluster. Then I'll put that image on the cluster and see that website. So that's the thing we are doing. And to do this, we will use Terraform to build that ECS cluster. So here again, all the steps are there and some notes are there. So how to do that? First, clone this Terraform workshop repository or download that zip file. And once you have downloaded it, go to that folder, Terraform workshop. This is that folder. So here I'll see the Terraform files .tf. These are all Terraform files. Different files are for doing different things. One is for creating, just like Cloud Formation. Here the main.tf is the main file that contains, like, defines what credentials are used to log into my AWS. So I have run that all here. What is the region I am using? What is my S3 bucket name? That is defined here. That's the main file. Then there is a variable file which is also important. There you define like what is the name of the ECS cluster and so on. And then you have a ecs.tf that defines like what are the ECS variables that are used. So ecs.tf, here is the name of the ECS cluster, what is the VPC, what is the security group, which port will be open. So all that is mentioned here. Okay, spend some time on this file, read each of these resource and imagine like what resource it is building. Okay, this one is building a cluster. Okay, this one is building a IAM role. This one is building a capacity provider. Like that, just go through it and also learn Terraform a bit so that you will be able to understand. Now something important here is container definitions. So there is a file called container def.json where we are defining what is the name of the image. So just do a double check, whatever image we pushed, whether that is written in your file or not. 789,556, this one. Okay, 789,566. Okay, this is correct. Okay, because sometimes when you create a new repository and your account is not matching, then this one will come out as a different URL, so you might get errors. So that's why I just check that. And here is the definition of how big your Docker container will be, like CPU is 10, 256 MB RAM, and so on. So that is enough. So just recheck all these things. And then to run Terraform, first command is Terraform init. Don't worry about the commands. If you miss them, everything is here. So don't worry about that. So I'll just run it. What does Terraform init do? It initializes all the things that are written in the Terraform files. So it initializes means reads those files, checks whether all the dependencies are there or not, and loads them. Okay, so that is what it does. Then you can do a Terraform plan. Plan is like a dry run. It is not actually doing it, but it will show you what it is going to do. So you can run that. Okay, when you're doing it for the first time, you can run a Terraform plan. It will take some time and it will do an inventory, what it is going to build, and so on. So that is what it is doing. And once the plan is made, it will you can apply it if you are feeling comfortable with whatever it is trying to do. So what is the summary of the plan? It is trying to build 26 components and nothing changing and nothing is getting destroyed. So safe to do so. If something is there which is overlapping with it, it might destroy also. So you have to be careful in checking what is there. For us, there is nothing because we are doing a greenfield project, something new. So we are just creating. So after the planning, you do a Terraform apply. Once you apply, these things will be created automatically, just like Cloud Formation. So what will it create? All these things that was planned. So what was planned, you can see so many things will create. If you do this manually, it will take a couple of hours. So it will create a VPC, it will create a auto scaling group in Amazon to auto scale. Like if load is more, it can auto scale that cluster. So it will create a log group, like where it will store the logs. It will create a capacity provider, like this is a function that will increase when load is more. So you can say when 85 is the target capacity, more than 85 CPU comes, then do a scaling. So these things are defined here. And here you are defining that what should be in your web cluster, what is the name of your ECS cluster, and all that stuff. And there is in ECS there is a service that is created, that service controls which port it will listen to and so on. And in ECS there is a task definition that is created that controls what should be the different parameters to run that particular Terraform in ECS. Like in task definition, you define all the parameters required to run a particular service or a particular task in a ECS cluster. So that is defined here. And here different profiles that you have to run and so on, lots of information. So use that template only and make your changes only in the variables.tf file and in the main.tf file. Okay, so that will just allow you to create. So here it is asking us to whether we are sure to do that. So we are saying yes. So now it will start the creation. Okay, so meanwhile, let's take some questions while it is creating, because this is again going to take around 5 minutes and we'll be done if everything goes well. So if anyone has any questions up till now, you can ask.
Yeah, we have a lot of questions than before. Yeah,
We have already crossed the time also, but anyway, these things we had to cover. This is the last one actually.
Right. We try to close the questions because this is needed. So from Shiva again, do we have any dynamic blocks concept in CFT Cloud Formation the way we have in Terraform?
Yeah, we have it. But why do we have dynamic blocks also? And Cloud Formation is continuously evolving, like AWS is evolving it. But I am saying when you have matured as a DevOps organization, like you should be using Terraform. Why? Because it has many advantages. One is your application will be able to be very dynamic, as you said. For example, uh, something changes, then it will be able to maintain the state and accommodate that change. And most important, like all the high level people like CTOs who take decision makers, they will always want every infrastructure to be able to move to any cloud, like multi-cloud or be portable. They will say, okay, we have a new client who is in Azure, we want to bring it to AWS. So in
Right.
order to do that, you should stick to Terraform if you are doing good DevOps, because
Right.
that way you will be very independent to do that. Yeah.
Exactly. So I think cloud formation is something like vendor lock-in. So if you go,
Exactly.
you would
It is
like to.
good. Yeah, if there is no plan of moving, then do it. But in Terraform also you get resources more also. Like when you're hiring a DevOps engineer, you will see people with Terraform, comfortable with Terraform, you will get more. So that is also another factor, because you
Right.
in the end you need some people to execute them. Yeah.
Exactly. So we have another question. Let's go here. Could you please explain a bit about code deploy? How exactly it work? Where our application will run? Will that behind the server containers taken
Okay.
by the AWS?
Okay. So for code deploy, what is happening? uh, there are three things you have to remember when you're doing the AWS DevOps. For Jenkins, you have just a pipeline which does the commit, like pulling from the report, building it, and deploying. But in AWS, what happens? In code commit, it is a repository where you are committing. It's just like a GitHub. And code deploy is the phase where you are actually building and deploying it. And the code commit, code deploy, this entire process is being orchestrated by code pipeline. So three things are there in this repository, like in this DevOps tools. So code deploy is the phase where the code is GitHub or code commit phase, and then it will build it. So there will be steps that will define if build is needed or not. For example, in our case where we did that HTTPS, welcome DevOps people or whatever, so there you did not need a build because it's just a matter of running in Apache server. So that was simple. But if it is a Java or something, then in the code deploy phase you have to write maven build, uh, or to build that particular thing. Okay, so meanwhile we have seen that the Terraform is built. So let's go back and just check the ECR uh, should have the image. It has the image, and ECS should have a cluster there because we created a cluster using Terraform. So go to cluster. Here you can see Terraform workshop cluster is there. One service is also running. Very good. And we go inside it. Web service is running. So if you go inside, you will see tasks. So in the Terraform, I mentioned I need 10 containers, 10 Docker containers, so that if two go down, I will still be up. So it has created 10 containers. Till now, 9 is there, and I think one is still coming. So running count is 9 and desired count is 10. So we can have one more in some time. Okay, it is trying. It is not having a blank server to create the last one. So it is keeping on trying. When it will create the last server, it will create it. But since we have 9 and we have a load balancer, we will still be up. So let's see so how our website is working or not. So we will have to go and check where is our load balancer. So how do we check that? Let's go to details. Let's go to target group. There it will show like the load balancer URL, so we can go through that load balancer to check. So we have a target group here, Elastic Load Balancer. Here you can see load balancer. So if you click that, you get the load balancer console. And from that, you can get the DNS name. But in a real world, you will be creating a Route 53 www.xyz.com, whatever your company name is, and create a CNAME with this DNS so that your website will open. But for now, I am just opening this one. So this will take our traffic to that container where we are running the React web app, and the React app is up. It is interactive also, you can so it is working. It's not just a static page, it's interacting with you. So that is how we created the ECS cluster. And one thing that is funny is it is resilient. Like if you go to ECS, say something happened and 5 of your servers got down, but you have 10, your website should not go down. So what I'll do, like say I will just go to that web service. I will force a deployment. I'll kill 5, like out of 10 I make it 5. So it will update it into 5. Slowly it will start killing it. If you go to ECS, you will see it will start killing after some time. Like it takes some time to take in these commands because these are posted into the AWS and REST APIs, and they keep doing that. So after some time, you will see the running count becomes 5, but the website will still be up. So that is how it will happen. And it will also auto scale if load is there and so on. But you have to have resources. Like if you are going to auto scale, your account should have sufficient resources allocated to it. Okay. So here you will see in a while, it will start killing those instances and decreasing the running count. Okay, so that is you deploy on ECS. And yeah, one more thing, like which I did not cover, the cluster that we created in ECS was a EC2 backed cluster, because in ECS there are many ways you can create a cluster. Okay, if you create cluster manually, you will be able to see that. Like when you are creating a cluster, there is the option of using Fargate. This is the Fargate option. That means Amazon will manage everything. You don't have to do anything. Second option is EC2 backed cluster, the one which we did. So we are managing everything. We are managing VPC, we are managing subnets, everything. Here VPC subnet will be optional. Like if you want, you can, but Amazon will manage. So this is a bit more costly, but you're less headache for you. This one, if you have some good engineers, use this, less bill will come. And EC2 Windows plus networking, this is for running Windows clusters. And also EC2 allows you to deploy, create hybrid architecture. Like say you have a data center at your local, and you have AWS Cloud, and you also want to do both the things. Like your AWS should be able to talk to your local data center. You want to create a hybrid. So that also can be done in ECS. Like you can create a cluster where you can put your local machines as a part of that cluster. So those are the next level things. But for now, you just practice these things and learn more about ECS clusters, learn more about Terraform, and we'll do specific sessions in the future, like because only ECS for a day and so on. This was just to show you a high level what all different things you can achieve using DevOps. So that is it.
Absolutely, absolutely, Prasanjit. Yeah, it's not easy to cover ECS in a whole in 1 hour as a 300 level,
Right,
because ECS is consists of EC2 for Windows, EC2 for Fargate, EC2 as a ECS
right,
cluster. So it's not as simple as that. So you can do a lot of things with the ECS. It's a container orchestration tool. But
exactly.
anyway, we try to do as best, maybe in the future, to have
Sure,
one of the
sure,
service in the future. So meanwhile, what we can do is we can have some questions, then 5 minutes for the questions, then we start for the quiz,
sure.
then we close. Okay, so here
Okay.
we have, I think Josh is trying to do the GitHub, whatever we have shown in the first demo. Hi
Mm-hmm.
everyone, that appear that I have a problem. My API user resource handler returned me a message: your access has been denied to S3. Please make sure that
Okay.
you have a problem to get object for code pipeline. So
Mm-hmm.
I think he needs some
Okay,
permission.
okay, I got it. Yeah, Jose, you can try like for this. Normally, it depends upon what user is running this. So in AWS, your user should be having those privileges to able to be write to S3 and all that. So in order to do that, you can go to IAM if it is not already there, and provided some privileges. Like your problem is code pipeline is not able to read S3. Okay, so for that you can go to your user. Say for example, this is my user.
I think you just need to add permission to the user.
Exactly,
No problem.
exactly. So I have added one rule. I'll show you that one. Code deploy full access, like that. Code pipeline full access. These stuff I have added. So
Right,
you
right.
can add that, or you can go to quickly add inline policy, choose a service. Here you search for code pipeline. Okay, where is that? Okay, here you search for code pipeline. Then here you specify that you want S3 access for you want all the access for code pipeline, and that's it. And then review policy, and that way. I'll share you that JSON which I have created for full access.
All
So
right.
that way you can do it. Yes.
Just, I think we answered the question. So I think you missed some policy for the users you are trying to deploy. So you can check that
Correct.
policy. Otherwise, you try to add another policy to the user so that you don't have the problem for the deployment. Okay. So we have another question. So I think he's a beginner. Um, Hi everyone. Good morning, everyone. Thank you very much for sharing the valuable knowledge. And I would like to transform my career from front-end developer to DevOps engineer. Can you please give me a clarity on most challenging skills as a DevOps engineer? It's a good question.
Okay. Yeah, it's a good question. And because you are a developer, you would not take much time to transition into DevOps. So what you will have to do first is you have to, because you know the code and logic, you know how to deploy, you know the version control system, release management, that part. Just learn something about Jenkins and pipelines, how pipelines work, declarative pipeline. Learn about cloud, do a simple like AWS course, at least the basic level, and learn something about networking, because you have to build servers here as a DevOps engineer. You have to understand infrastructure, networking, all those stuff. So cover those things which you do not know, like networking, operating system, cloud, and rest of the things will be natural for you as you are a programmer.
Right. As I just also I'm trying to add one more point. So for the developer, it's not a problem for you because you are the coder. So for example, if an engineer, infrastructure, Linux admin who's trying to be a DevOps engineer, he need to write some script, he need to write work on the cloud formation, JSON,
Exactly.
YAML. So for you, it's very easy to write infrastructure as a code and deploy and debug for you easy. So I think it's a good time to you to become a DevOps engineer?
Yeah, for people like me, it took a lot of time. Like it took more time because I am not, I was from an infrastructure background.
Yeah, it's
So it was the
for me
other
also
way
same.
around. So
For
I
me
have to
also same.
learn the scripts and Python and all those, and still learning, like
Yeah, yeah,
because it, those who are non-coders, they are forever learning code, and it doesn't come easily. Yes,
yeah. For developer, it is more advantage to become an
yes.
infrastructure and DevOps engineer. That's what I can say. Okay, so we take another 2 minutes, then we'll start the quiz. So meanwhile, we will take another questions from Shiva again. So, what is the high availability of ECS cluster? Let's say if one.
Sorry, I lost you for a while. Hello.
Uh, I'm here. So I lost
Sorry,
my network.
I think, yeah, sorry, I lost. Can you please repeat the question?
Yeah. So what is the high availability for ECS cluster? Let's say if one region goes down, then what will be the solution for H? Never see a region goes down before. Maybe an availability zone, yes,
Yeah, yeah.
but not regions.
Yeah, that's like region going down will be very rare, but that also can be done. But normally, what happens? You saw in ECS there was a load balancer, so you can have multiple of those load balancers. Like each load balancer will have a target group where it will listen on a port for that service. So if you are deploying multi-region, so you will have another same similar cluster in that other region with its own load balancer, and between those two load balancers you put another um, uh, load balancing layer. How you can do it using region based uh, DNS, like you will use route 53
I
to
feel
quickly switch to the, yeah, so that way you can do region based.
right. So
Everything is possible in
it's
AWS
something
now.
like it's something like not HA. It's something like a DR. It's something like
Exactly.
active disaster recovery where you
Yeah,
can
and
do
for H,
something like
exactly.
same infrastructure,
You are right. You are right.
as said, as Prasanjit, what you can do is you can have a route 53 failover for the two regions. Let's say A goes down, let's automatically switch to the BC, so that will be taken care of from route 53.
Correct. And for HA,
So
you
I
are
think we
already
answered the
having those 10 containers. Like you have 10 containers, or you can scale it up. If two of them die, still the site is up. So that way, HA will keep happening. And if you want region or availability zone based, you can do the DR based thing.
right. Absolutely. So okay, thank you very much, everyone. So let me start the quiz. So I think we are out of time. So we lost
Yeah.
more than enough time. Something I can say. Okay, so I'm going to start the quiz so that you can join the quiz. So let me share my screen for a moment. Sorry guys, if I miss your question, try to get back to you in the meetup group or in the YouTube channel because we are out of time. So let me share. Okay, so this is here. So guys, I think I'm sharing my screen, but it's not appeared. Uh, pop, 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 pop. Right. Hope you see, there is no screen. This is a window, and this is on. Okay, guys, I'm sharing my screen, but it's
Yeah,
okay,
we can
guys. You
see.
can join the yeah. Maybe I go. May me and Prasanjit go off. it's good. Nothing. It's better than nothing. Right. So you got 4 out of 5. Congratulations again. Be sharing you a 24 hours credit of AWS coupon after the session. So if you miss that, you can get back to me. I think this is the second time you're for leaderboard first prize. Thank you very much. And let me going back again to my presentation. I'm here. Okay, so we are here. So guys, if I miss something, if I miss answering your questions, because we got a lot of questions, we don't have a lot of time today, and we are trying to cover 2 demos. And Prasanjit had done as best as to cover all the same session. And as you can see, we are on social media. You can join at AWS User Group Malta in Facebook, and you can follow us in Twitter, and you can also join a Slack channel. So whenever you need me directly, I will be trying to help you in a way. Okay, so thanks for joining with us. AWS User Group Malta, and this is our final episode. So we look forward to host another sessions in the future with Prasanjit Singh based on his availability, and he's done a good job for us. And he's given a time not only for the one session, for the 3 sessions. So we really need to appreciate him from our side. So from AWS Malta, from AWS Group Malta, we are really thankful to you, Mr. Prasanjit Singh, because these sessions is most valuable at the moment. Why I'm saying it's because, as you can see, we have a pandemic, and there are a lot of people lost their jobs. So their families suffer with. Even I have seen my friends or somebody who is facing more problems because of losing their jobs because of the pandemic, so that maybe they can get skill ups or and the cloud technologies to get another job. Thank you. Thanks again, and this is
Thank you.
a great
And there are some more questions, but I'll answer it on the YouTube comments. I have noted those questions. I will put it
all
there.
right. Thank
Thank
you.
you.
Thank you very much. Have a good day. Bye bye,
Thank you,
guys.
everyone.
See you next time. I'm sorry, I missed one thing, guys. So we are hosting 2 sessions, another 2 sessions in the month. One is a Chaos Engineering. This is one of the best, I can say, because it's cover the best practices. How you do with the Chaos Engineering. Chaos Engineering, one of the methodology. Maybe you can try to attend the session, because Veliswa Boya is a senior DevOps senior advocate in the Amazon Web Services, and we have Zamira is one of my ex-colleague, and she's hosting a security on AWS. So try to RVSP, yes, and try to attend the live streams too. Thank you very much. Have a good day. Bye bye.
Bye.